कर सकते हैं?
Yes, yes.
A very good afternoon to one and all. So our expert will be coming shortly in 5 minutes. She got stuck in the traffic jam. So now I got the call from her. She'll be there around 5 minutes. So we'll just start in 5 minutes. So today's our expert is Dr. Anu Singla. She is an associate professor at Chitkara University and she is an energy auditor also. So the mainly this lecture was given to her because the energy audit, a general person talking about energy audit and an auditor talking about is different. So that's why we have just called her, and she has also conducted audits, and I think she has very good material regarding these energy audits. And I think all the centers also please note this. If you people are interested in writing this exam of energy auditor, or if your students are interested, you can even ask her about what is the procedure and how to become an energy auditor. Like apart from your work, side by side you can also do this, so that also you can just note it down, how to become an energy auditor, like so what are the steps and all those things. And we have some small change in the timetable also. I think I have sent you people the Homer lecture which was planned on Thursday. Thursday it was from 9 o'clock, but the expert, he is coming from out of station, so he wanted to keep it in the second, like 11 to 11:45, from 11:45 to 1. So the Homer lecture will be from 11:45 to 1, and in the afternoon again it will be continued from 2:15 to 4. So Homer will be adjusted like that. And the afternoon, in the Thursday afternoon, the power quality issues, that will be kept in the morning first lecture, like 10 to 11:45. So that one small change we have done there, and otherwise I think the other timetable is okay. So if you have all the centers, I want to make one more announcement. I think you would have done the registration, and I think you have all the participants list. So all the coordinators, please send me the list of participants, especially in the format which I have sent you, because always we get the participants list in a word form or different, but we have to send it to one of the department where they make the certificates. So they want it in the Excel form. So for every coordinators I have sent the format. If any of the center they didn't get it, please you can just inform me now so that I will resend it. Okay, I have sent you format, Excel format for participants list. So I want you people to fill the participant list and please send it to me within this week so that we can also process it. And the bills also, the like stationaries and consumables, the bills which you have which you have got, please keep that safe. And once the course is over, along with the attendance, I think you all are taking attendance morning and afternoon. So with the attendance sheet, with the list of participants, and with all the bills, you will be sending it back to me in the next week. So please, only 7 centers are there. So you can, all the centers, just those who, if the coordinator is not there, please inform the coordinator. And I just want the list of participants by Friday, so that I can start the process of certificate. Okay, so this is the announcement for the centers. And tomorrow morning we have Sutpreet ma'am. Like I have written SLS, but it is not me. You have an expert. I have sent it in the new timetable. So she is from UIT. She's associate professor at UIT under Punjab University. So she will be giving you on energy efficient technologies.
Hello, ma'am.
Yes, sir. Once again, I couldn't hear. Yes, sir.
Madam, we have received the schedule, but
Yeah.
we have not yet received the said format.
Okay, okay. Yeah. I remember. Vyas College, is it?
Yes, ma'am. Yes.
Yeah. For others, I've sent Vyas, like only that schedule I've sent. I'll be sending you today itself. Okay.
Fine,
Now,
ma'am.
once my expert is here, I'll be going back. So I'll be just sending you the other
Sure.
details. Yeah, you
Thank
should have the attendance sheet also, sir.
Yes,
Attendance
we are
sheet
having it.
in the afternoon. Then have the
Yes, ma'am.
feedback form. So I want all the centers to fill the feedback form on the last day. So that also you will be sending it with the bills and all those things. Okay, so like
Fine.
I'll be just sending. All the other colleges I have sent, I think their experts will have. Vyas Institute and Technology, I'll be just sending you the details. That I'll do.
Thank you. Thank you.
And the participants here also. And participants here also, like if you are interested, say we have a solar wind PV system in our lab. So after 4 o'clock, the demo is going on with fuel cell is also there. You can also join us. After 4, you can just come to the power electronics lab. Yeah, the electrical engineering department, ground floor. Electrical engineering department, you come to the power electronics lab. There you can see hybrid wind PV fuel cell battery system. So it's a hybrid system. We have other systems also. You can just come to the lab and have a look at it. Okay. Okay, मुलाना की भी मैं भेज देती हूँ because I think मुलाना also like वो उनकी कोऑर्डिनेटर अभी चेंज हो गया. पहले अखिलेश, हाँ अभी विकास सर है. ओके, मैं उनको भेज देती हूँ. उनका भी मेल आईडी मेरे पास है. मुलाना एंड ये भेज देती हूँ. So our expert, सुन रहे ना those people? So our expert has come and I've already introduced you and I've so we'll just. आपका पेन ड्राइव है और हाँ पानी चाहिए मैम. एक मिनट. ओके, यहाँ है. Energy audit, February 9. That is the thing, no? This I'll keep it like this itself, no? You want to? Should I put it in the laptop? Only this energy audit or other things also? Only this. You can come here. No, campus. I've introduced you. I told you an energy auditor also. So कुछ आवाज का भी पूछेंगे.
So should we start?
Yes.
Very good afternoon to all, and I'm extremely sorry for being late. So today is the topic of discussion is about energy audit. So before we start with energy audit, I will cover a bit detail of what is the energy scenario in our country, why is there is a need of energy audit. Then I will be covering what is the methodology to conduct the energy audit and how to prepare the reports and all. Then I have taken a case of the electric motors. Then there is one small student activity which can be done at our institutional level. Now, if we see India's energy scenario, India is world's third largest producer of electricity in the year 2013 with 4.8% global share in electricity generation. India was ranked 6th in annual electricity consumption, accounting for about 3.5% of the world's total annual electricity consumption. And if we see that the annual electricity generation consumption, it has increased about 64% in the past decade, and its projected rate of increase is one of the highest in the world. India was the fourth largest consumer in the world of crude oil and natural gas. After the United States, India imports about 3/4 of crude oil, and country's oil bill accounts for 37% of the total value of all imports. Excuse me, the images are not coming up. Yeah, the photographs are not there.
मैम आपने लिंक दिया था ये कहीं से?
No, no, these are the images.
वैसे बता दीजिए, स्लाइड शो मत कीजिए तो वैसे
हाँ जी मैम, स्लाइड शो जहाँ पे इमेज है ना, यहाँ भी नहीं आ रही है।
यहाँ पे स्लाइड शो मत कीजिए, यहाँ पे ऐसे बता दीजिए, नहीं आ रही
यहाँ भी नहीं आ रही है इमेज।
Should we restart our system?
सिस्टम की प्रॉब्लम नहीं है मैम, आपने ना आपका मैक तो नहीं है मैम सिस्टम?
No.
मैक होता तो प्रॉब्लम हो जाती है।
Open the recent documents. Click yes.
नोट करना है ये आ रही है बस। मैम आपके लैपटॉप वहाँ से कनेक्ट कर देती हूँ।
Sure. Kindly wait for 2 minutes. There is some problem regarding the images in the PPTs.
आप बाद में ऑन कर लीजिए। ऑडियो जाएगी वहां से, इसे ऐसे रहने दीजिए, यहाँ से ऊपर इतना करके
We continue with the discussion. So it was like India was the fourth largest consumer in the world of crude oil and imports about 3/4 of crude oil. And if we see 68% of our population lives in rural India and 80,000 villages, they are still unelectrified. At one scene in the urban areas, we talk about the traffic jams and all, and there are certain areas where the people, they have to walk miles to fetch one bucket of water. At one time, we talk about the models of the cars, bikes and all, and there is another scenario of the country where the people, they don't have any mode of the any transport mode. The government is talking about the rural telecom, rural banking and all, but all these things, they will not work well without a stable power. And if we talk about the electricity energy consumption in the field of agriculture, India is highest with 18%, followed by Iran and Pakistan. If we talk about the traditional fuels, we no doubt we are using LPG gases at our homes and all, but there are nearly 800 million Indians which use traditional fuels, and these traditional fuels, when they are burnt in the chulhas and all, they release large amounts of pollutants, and nearly 3 to 4 lakh Indians die of indoor air pollution and carbon monoxide poisoning every year because of biomass burning and use of chulhas. And if we see that there are cities where there are no power cuts, but when the power cut occurs, even inverter is not working. This is the normal scenario in a normal family of the country. So it means energy matters for all of us. And if we see what will be the forecast of the energy in the years to come and all, global demand for all energy sources is forecast to grow by 57% over the next 25 years. 56% of the world's energy use will be in Asia by 2030, and India's demand for all types of energy is expected to increase by 41% within 25 years. If we have to meet these energy demands, we have to add the power generation capacity. So nearly 300 power plants, each plant of 1000 megawatt capacity is required to meet demand by 2030. So it means there is a lot of generation. We are producing electricity and all. Still, there is a deficiency of the power. At one time, there are no power cuts, and there are certain areas of the country which are still unelectrified. So it means now there is need not only to talk about the generation, but we have to work on the demand side also. So we have to manage our demands. And so that's the only solution, that reduce demand through energy efficiency and conservation. So there is a dire need of energy management in current scenario. And if we talk about the pyramid of the energy management, is energy conservation, which is followed by energy efficiency, that is adoption of energy efficient technologies, then moving from fossil fuels to the renewable sources of energy. Because when we talk about the energy management and all, at global level, there is a concern of global warming, climate change and all. For national, we want to improve our energy security by reducing the dependence on the imports. And when we talk about the common person and all, we want, any industry, it wants to reduce their energy bills and all. So if you see what is the potential for energy conservation in different sectors of the country, so this is some of the data that if we talk about the major energy intensive sectors, then we can see from this data there is ample scope of energy conservation. And if we talk about India, we have the high level of energy wastage, and energy intensity per unit of GDP is 3.7 times of Japan and 1.5 times of the USA. I have just taken example of three sectors, aluminium, steel and cement, and we can see that how much energy we are consuming per ton of the production vis-a-vis the world scenario. And when we talk about the Indian industry, there is a large benefit of specific energy consumption across the industry. We have latest modern plants with very low specific energy consumption, and then there are some industries which are using obsolete technologies. So that bandwidth of specific energy consumption is very large in our country, from modern plants to the outdated plants. So what is the role of energy audit in this scenario? Energy audit will help in identifying the areas where waste is occurring and where there is a scope of improvement. So primary objective of energy audit is to determine ways to reduce energy consumption, hence reducing the energy bills. And when we talk about energy, we are talking about electrical and thermal energy, so electricity as well as the fuels which are being used. And if we see what is the electricity consumption across the different sectors, then we see that industry consumes 44% of the energy consumption, and which is followed by the domestic sector, which is 22%, and then followed by the agriculture sector and the other sectors. So today I shall be talking about what are the energy, how to carry out the energy audit in an industry, and it will be followed by one small example which is applicable to any buildings. So that is mainly covering the domestic sector and applicable to industry also. So when we say that our industries, they have to become globally competitive, then their products, they have to be energy efficient, and the production process, it should consume the least amount of the energy. So energy audits and conservation studies, they must be conducted in all types of industries at the regular intervals, although it is mandatory for the energy intensive industries, but all the industries, they should follow this practice. And when we see that what are the major components which are consuming energy in the industry, in general, it's the electrical system which comprises in lighting, electrical motors, then we have HVAC systems, compressed air systems, fans, blowers, boilers, refrigeration and drying unit. These are the major components which consume energy in any general industry. And energy management is basically defined as the judicious and effective use of the energy to maximize profits. And if we talk about what are the 4 pillars for the successful energy management program, first is technical ability, then there should be a very effective monitoring system, then there should be strategic planning to implement the energy management programs, and above all, the things flow from the top management. There should be a support from the top management to carry the energy management programs in the industry. And energy audit is basically a key to a systematic approach for decision making in the area of energy management. So when we say that we have to manage something or we have to carry an energy management program, it is based on some of the data analysis and all, some of the recommendations. So all data analysis, everything is done through the energy audit. So if we see that how the Energy Conservation Act 2001 defines energy audit, so according to it, energy audit means the verification, monitoring and analysis of use of energy, including submission of technical report which contains recommendations for improving energy efficiency along with the cost benefit analysis, and then an action plan to reduce energy consumption. So this is the precise definition of the energy audit as per the Energy Conservation Act, which includes everything with a follow-up action. So for any industry, there are the three top operating costs. One is of energy, another is labor, and then there is a materials. And if we see amongst three major energy cost components, energy has the highest potential for the cost reduction, especially for the energy intensive industries. So what energy audit does, it basically balances the total energy input with its use. It identifies all the energy streams in a facility, and it helps to understand about the waste energy is used in the industry, and we can identify the areas where the energy is wastage of energy is occurring, and where we can improve the energy conservation in the process. Now, there can be different types of energy audit. The type of energy audit performed, it depends on what is the type of the industry, what is the depth to which final audit is needed, and what is the potential and magnitude of cost reduction desired by the industry. So accordingly, we can classify energy into three types. One is the preliminary energy audit, the second one is targeted energy audit, and third is the detailed energy audit. When we talk about the preliminary energy audit, it's a simple walkthrough audit that you just go to the industry, meet some people, and just go through the plant to get familiarized with yourself. Then there is a targeted energy audit, which provides the data and detailed analysis on the specific target projects. Like say one industry wants to carry out the audit for say lighting system, or they want to work, there is a leakage of the steam and all, they want to get the energy audit of the steam system. Then the targeted energy audit is done for some parts of the industry. So in this audit, we do the analysis of the energy flow and what is the cost associated with that specific area that part is being done. And when we talk about the detailed energy audit, basically it's a comprehensive audit and results in a detailed energy project implementation plan for a facility. So it includes detailed energy cost calculations and project implementation costs, and this audit is carried out in three phases. So first is pre-audit phase, then it's a audit phase, then it is a post-audit phase. To carry out the detailed audit, there is a 10-step methodology, which is the standard procedure to carry out the energy audit in any of the industry. So there is a phase one, pre-audit phase, that is step one. So it is like a walkthrough audit, which we talked about the preliminary energy audit. It's just the person goes to the industry, meet with people, and it's an informal kind of interaction. And the purpose is that we organize the energy audit team, and then we need to find out what is the instruments required. Then some macro data collection is made, and then there should be familiarization with the process of the industry. Then there is an introductory meeting with all divisional heads and persons concerned with energy management. It is done just to build the rapport and with the team, because when the audit is being conducted, is not only external team, there are some members from the industry which form a part of the team, which provide all the inputs and all. Then there is a audit phase. After getting all this data, then we get the primary data gathering, that is process flow diagram and energy utility diagrams. So we take the data from the invoices, what had been the electricity bill, what had been the fuel consumption of the process, what is the production, what is the fuel consumption, then what are the then accordingly we take the single line diagrams, then what is the compressed air and steam distribution, and accordingly we prepare the flow charts. Then we design operating data and schedule of operation, and the inputs they are taken from the electricity bill, and we study what is the energy consumption pattern. Then the survey is conducted, that is the step 4. After getting all the data from the industry and all, then the survey is conducted and the data is being monitored. So we may have to take some of the measurements and all, which are elaborated later on also. That is like what is the motor survey, what is the lighting, what kind of lighting systems are being used. Then there may be some of the existing instruments, and we work out if some additional instruments they have to be deployed to take the readings and all. Then there is a conduct of the detailed trials, that is step 5. That is the monitoring of the power factor energy of the plant. Then what is the load variation trend in pumps, fans, compressors. Then boiler efficiency trials, furnace efficiency trials. And accordingly, then we step 6 is the analysis of the energy use. We make the energy and material balance, and we work out what is the energy loss in the whole process. We make the flow chart and we take what is the energy input and what is the production, and throughout the process what are the energy inputs and where the loss is occurring. So in 7th step, we identify and develop the energy conservation opportunities. We work out, okay, this is the complete process and this is the load pattern and all, and this is the measurement data says, and accordingly work out what are the energy conservation opportunities in different processes, and those things they are being discussed with the internal team also. Then after giving the recommendations and working out like what kind of energy efficiency opportunities are there, then cost benefit analysis is done. We work out what is the technical feasibility of the recommendation and what is the economical viability of the project, and accordingly we set the priorities for the recommendations. The most promising projects, they are selected immediately, and there are certain recommendations which involve high cost and they need the approvals from the management and all. So those things they are being put at a later stage. So these things, all these points, they are discussed in the subsequent slides also. Then all the things are documented, and then draft report is being ready and the presentation is made to the management. Then after the getting the feedback from all internal and amongst the team members, the final report is made. Then the third is the post audit phase, where the follow-up action is also taken. So after recommendations are given and all, we prepare a action plan for the recommendations. Then we monitor that if those recommendations are incorporated in the plant, then what had been the energy inputs and all, how the process has improved. That is a periodic review of all the recommendations made and the follow-up action. So I discuss all those points into a bit detail. So we had 3 phases. Phase 1, that was the pre-audit phase, in which the team visits the campus. It basically walk-through audit, and the main aim is to finalize energy audit team to identify the main energy consuming areas and plants to be surveyed during the audit, and to identify the instrumentation required for carrying out the energy audit. And then we see that the instruments already installed in the industry, are they sufficient for our purpose, or we have to install some of the instruments to take the readings. Then we analyze the major energy consumption data with the relevant people, then obtain all the drawings, and again create the awareness through meetings and program in the employees of the industry. And during the phase 2, that is the detailed energy audit activities, where we conduct the survey and take all the readings and all. So the information to be collected during the detailed audit includes energy consumption by type of energy, by department, by major items of process of equipment. When we say type of energy, it means there may be different kinds of fuels are being used, and there is a electricity consumption. So we put, okay, electricity is consumed by these processes, say this fuel is consumed by these processes, then which department is there, so accordingly we work out. Then we make the material balance data. So material balance data means what is the raw material used, then what are the final products, whether recycled material is used, if there is any byproduct, or if the byproduct has to be reused in the industry, or there is some waste heat recovery and all. Then we study what is the energy cost and tariff data. Then what is the source of energy supply, whether there is some captive power plant, there is self-generation in the plant, like some of the industries, they install their own power plants and all, or if the electricity is taken only from the grid. So these certain parameters, they are being stated in detail during the phase 2, that is the main activity, that is the audit phase. Then we take the process and material flow diagrams, the whole industries from the simple starting from the raw material to the final product. The complete flow diagram is made, like how the energy is flowing, what are the steps involved, what are the different processes of the industry in during the whole complete process. Like there are different stages for the final product to be made. So during each stage, what kind of energy is being used, what process is being followed, and what energy saving opportunity is available where any leakage or wastage of energy is occurring. Then what is the potential for the fuel substitution if the process has to be modified, or if there is a use of the cogeneration system. If there are already some ongoing energy management program, then those programs, they are being reviewed. So when the audit team enters the industry and takes all the data, so these are some of the points, some basic data which needs to be collected from the industry, like what is the quantity and type of the raw material used in the industry. Then what is the technology, what is the process used, and what are the details of the equipment. So sometimes the process is such that there are certain new technologies involved which make the process shorter and make the process more energy efficient. Then what is the capacity utilization, what are the efficiencies, and what is the production yield of the plant. Then what is the percentage rejection, what is the reprocessing, what is the quantity and type of waste occurring in the industry. Then what is the consumption of the fuel, steam, electricity, compressed air, cooling water, chilled water. So these are some of the tips, some of the data which is to be taken for the energy audit of the industry. And there are certain tips which if we follow them, we can avoid our time in collecting the data and all. So one thing is that measurement system should be easy to use and provide the information to the accuracy that is needed, not the accuracy that is technically possible. So take the data in the form which is required for your calculation purpose. Sometimes like because we have to find out the energy saving opportunity in that process. So accuracy up to second decimal or third decimal may not be required. We just want to know, okay, what are the inputs and how the process is taking place. Then the quality of the data should be such that the correct conclusions can be drawn. Sometimes what happens that we take the data, but when we sit to analyze the data, then we are not able to conclude anything from the data. So then the whole exercise gets wasted, and then again we have to get to the plant to work out the additional data. Then we must know that if I have to work on this process, then what should be the frequency of the data collection. If the data is to be collected on the hourly basis, or 3 times a day data is required, or some weekly data is required. So it depends on what kind of process is there. Then what are the data has to be collected when the machine is starting and when the machine is shut down, because during the starting it may draw a large amount of the current, and then what is the power flow when the machine gets shut down. And sometimes it's not possible to take the measurements. In those cases we can take the design values or the readings on, or the specifications from the nameplates to take the read. Now, once the data is being taken and all, just draw the complete flow diagram and list the process steps which I have discussed earlier also, that there is a complete process flow diagram that from raw material to the final production stage, what are the various steps involved, and all the steps they are being listed. Then the complete energy flow diagram is drawn, and from there we find out where the energy waste is occurring. Then we need to work out what are the energy conservation opportunities. Like when we sit for the first time that okay, we have taken all the readings and all, then broadly there are 4 categories where we can work out that what are the energy saving opportunities. First, say we are talking about the electricity and the thermal energy. So when there is any fuels they are used in the process and all, then we fuel substitution is one of the opportunities to save the energy. So just find out if the existing fuel can be replaced by appropriate energy efficient fuel. Then when we talk about the generation process, then find out if we can find out any energy efficient opportunities in the energy conversion equipment, such as captive power generation, cogeneration, steam generation in boilers, then optimal, if DG sets are normally used in all the industries, either for the peak load or whenever there is a breakdown of the grid. So what is the optimal loading and high efficiency of the DG sets? Then what is, if the boilers are being used, then what is the minimum excess air combustion? What is the optimizing existing efficiencies and all. Then we talk about the energy distribution systems. We can work out where are the energy efficient opportunities exist, like in transformers, cables. See, if there are loose joints of the cables, the terminations are not done properly, then lot of energy gets wasted. And sometimes the cables are overloaded. If they are not sized properly, then again power loss is occurring. Then what is the switchgear? If the power factor needs to be improved, then compressed air systems, cooling water. So the complete energy distribution system. Then what is the process of the in the industry? Now this is the area where there can be like some of the plants when they are updated. Updated means they have changed the technology. The process to develop the product has been changed. So this is the main area where the energy saving can take place. And when we work out what are the power costs in the industry, when we see the electricity bill and all, we have to see that electricity bill is based on which components. Like utility charges the bill on different components, like maximum demand charges are there, then energy charges are there, then time of day charges, whether peak demand or non-peak period. Then power factor charges are there. Then there are some incentives and penalties which are offered by different electricity boards. Then high tension tariff, low tariff rate charge, slab rate cost and its variation. Then type of the tariff clause and tariff rate for developed and underdeveloped areas. So the auditor, it has should have the understanding of what are the different components of the tariff, and for on the basis the electricity bill of that industry is coming. So sometimes like say shifting the process from peak hour to non-peak hour can result into the energy saving. Sometimes there are certain due to because your demand has exceeded the level, so there are certain penalties which are being put by the industries. So that components they can be worked out, and we can see to it that how the energy can be saved, like how the electricity bill can be improved by just making some changes in the system. So power cost and the fuel cost, both the understanding of the energy cost is must. And when we say fuel cost, there are wide variety of fuels which are available for thermal energy supply. Some of the commonly used fuels in the industry are fuel oil, then there is low sulfur heavy stock, then there is a LPG gas, coal, lignite, wood, etc. Now, availability of the fuel, the cost of the fuel, and the quality of the fuel, they are very, very important. So when we see that what is the cost of the fuel, we just don't see what is the cost of the fuel, but what are the transport charges involved, what type of transport is involved in the fuel. Then what is the quality of the fuel, if there is any contamination, whether there is any moisture.
Commercial or
This is Ranjay Singh from DIT University.
Yes, sir.
Ma'am, could you please switch back to the previous slide?
Yes, sir.
Ma'am, what I'd like to know is that our residential complex also charged for the reactive power they are consuming, or for having a poor power factor as a residential load.
Sir, please will you repeat your question? Normally, reactive power factor penalties are given in the
industries are concerned. As far as the industries are concerned, they are charged for their kVAR rating and kilowatt rating for both of them. For the residential complexes, do we? I mean, are we charged, or is there any prospect or of the residential load being charged for their kVAR rating as well?
No, sir. Actually, they are not charged for the meter. They are charging for the kilowatt hour. And what is the energy consumed? So that takes care of the power factor also. So reactive component is not separately charged for the residential. And coming to the industry, now like Punjab, even the industry is charging on the base of kVA now, not on the kilowatt hour now. So this is a recent development in the electricity boards that they have started charging the industries now on the basis of the KVA. So even that is one amendment in the tariffs for the industries also. But
are there any prospects for residential load also being charged in form of KVA rather than kilowatt hour?
Sir, may the times to come, it may be getting implemented for the residential consumer, but it will come after a long time, because first the industry, they targets the bulk consumers, then commercial consumers, then it comes to residential.
Thank you, ma'am.
This was about the understanding of the energy cost, fuel cost, as well as the power cost. And when we collected the data from the electricity bills and other fuels, now we check the invoices of the industry, and we can work out what has been the total cost of the energy bill of the industry. Then all the fuels purchased by the plants, they should be converted to common units such as kilocalories. Then we work out like what is the major component, which component of the fuel is a maximum, like energy bill is maximum for which kind of the fuel. Then we find out the energy consumed for the period. That is the formula C plus M into production for the same period. Now C is the constant cost, so whether there is any production or not, that cost will definitely occur because of some lighting, general ancillary services, heating, cooling and all. M is the energy consumption directly related to production, so that is production for same period. So we calculate energy consumed for the period, and then we find out the standard energy consumption for any level of the production. So this is how we work out that for producing 1 unit of the product, what is the energy input there. So what is energy consumed per unit product, like a product, whether it's in the form of number or in the terms of tons or all. Then when we talk about the fuel and energy substitution, the fuel substitution is basically substituting existing fossil fuel with more efficient and less cost, less polluting fuels such as natural gas, biogas and some other locally available agro residues. Now examples of fuel substitution are like natural gas is increasing the fuel of choice as a fuel, then replacement of coal by coconut shells, rice husk, then replacement of light diesel oil by low sulfur heavy stock. So it means energy dependency can be reduced by 2 methods. One is energy conservation, another is the fuel substitution. So when we talk about the substitution, it is basically either fuel substitution or energy substitution. So example of energy substitution is like we replace the electric heaters by the steam heaters, and if there is a steam based hot water, that can be replaced by the solar geysers. So this is where we can save the energy. And when we say what are the energy efficiency measures, then there are some active or efficient in-house management of energy efficiency through maintenance and housekeeping measures, and it may involve or it may not involve any of the costs. Say sometimes there is a place some leakage is occurring, you plug the leakage, there may not be any cost involved, but energy is being saved. Some motor is idly running, you change the process, there may be some cost involved or there may not be cost involved. So these are some of the in-house management of the energy efficiency. Then there may be a requirement of the replacement or retrofit of the selected equipment, which may require medium-sized investments and can be taken up. Then the final type is that there is a modification of entire manufacturing process which require the large-scale investments. For that decision has to be taken by the management. Is basically high investment but high returns. And normally these kinds of energy conservation measures take long time to get implemented. So first thing, it takes a lot of time to get them approved, then the implementation stage comes. But yes, there are high returns on there. And sometimes what happens that although options are available, but the company has not enough money to go for the change of the technology of the plant. So once we work out what are the energy conservation measures in the plant, we study the different kinds of processes. So there may be different kinds of equipments involved, and we may work out what are the energy conservation opportunities. We provide our recommendations. Now the recommendations, they have to be technically checked, and we have to work out whether they are economical or not. So technical feasibility should address whether the technology available, whether there is enough space to incorporate that technology. If manpower is available, say if the industry, they don't have the trained manpower, and we talk about the new technology, it means enough time will be required to train the manpower, and sometimes the people, they are not, see, there are the old industry, there are very old technicians working there, so it may not be sometimes in a position for to them train to the new technologies. Then what is the impact of the energy efficiency measured on the safety, quality, production or process? Then what are the maintenance requirements and spares availability? There, what happens that like in the normal cases is also there, that new technology is available, but the spares are rarely available or they are very expensive, and some equipments, they are very sensitive to environmental conditions and their maintenance requirements are very stringent. So when we recommend any technology, or we just offer, okay, this is the energy saving conservation, we have to thoroughly see whether it's technically possible or not within the constraints of the industry. And when we talk about the economical analysis, we can work out the economical feasibility of that recommendation by different methods. Simple method is the payback method. Basically, we want to work out that how after how many years the investment makes money. Then there is a return on investment. Basically, it's a measure that that allow comparison with other investment options. Then the third most important is the net present value method. So basically, it is a measure that allows financial planning of the project and provides the company with all the information needed to incorporate energy efficiency projects into the corporate financial system. A very simple and very basic example is that like say we have to say that solar like we want to install the solar power plant in the industry, because there is a all solar geysers are required and all. Now see, if we have to invest the solar power plant, although it's not a very basic example, now some investment has to be made by the company. So they have to see whether they work out the complete details. If we install the solar power plant, how much energy is made, how the DG cost can be replaced by the solar power plant, or if they are not using the DG sets, then it may happen that the electricity cost may be less than the cost involved in setting up the power plant. But there are certain processes in the industry, if we change them, there will be a huge investment required, so that net present value has to be find out for that new implemented project. Now, when we say that we have worked out the economic feasibility, this is basically a format by which we can work out that say we work out what is the energy efficiency measure. Then there are three columns. What is the investment required to implement that energy efficient measure? Then what are the annual operating costs? Then what are the annual savings? When we talk about the investment, means what is the cost of the equipment? What will be the civil work required? What kind of instrumentation required? Or if the existing instrumentation will be enough, or some new instruments will be required, or if there are certain auxiliaries required to implement that new technology. Then what is the capital cost? What is the maintenance? What new manpower or existing manpower required? What will be the energy consumed by the new process, and what will be the depreciation rate? Then we work out what are the annual savings. Annual savings can be in the form of thermal energy, in the form of electrical energy, in the form of raw materials or waste disposal. At some of the processes, waste disposal itself is a energy intensive activity. Accordingly, we work out what are the net savings per year. Then we find out the payback period in months. Now, in the complete process, say there are 10 recommendations or there are 15 recommendations. For every kind of recommendation, this kind of a format will be prepared. The auditor can use any other method to do it. This is one of the formal way of putting the things into the document form. Then whatever the energy saving measures they are suggested by the auditor, we put them into three categories, like low cost, medium cost, high cost. So there may be some of the projects in most of the industries you find that the cost involved is very low, but the returns are very high. Then there are medium cost, medium return projects. Then there are the certain projects where we some retrofitting or some technology has to be changed that in calls for high cost, but the returns are also high. So normally we set the priority for the projects. The low cost, high return projects, they receive the maximum priority. But the projects which are related to high cost, although returns are high, but they need a careful scrutiny before the funds can be committed. So it means in the first sheet, we gave all the energy efficient measures, we did the payback period. From that data, we set the priorities, we work out what are the low cost, medium cost and high cost. We categorize accordingly. Now, then we set a priority, project priority guideline. Like say there are 10 recommendations, then we categorize them in low cost, medium cost and high cost. Then we set the priorities like A, B, C, D. These are some of the priorities. Like we set the priority A. We work out the three columns, what is the economical feasibility, technical feasibility and what is the risk involved. Now A means say is a very good project. Economically, it is very well defined, very attractive, existing technology is adequate, no risk. So we put it highly feasible project, and these projects they normally go get a signal of go ahead immediately. Then the category B, B means the project is well defined but marginally acceptable. The existing technology may be updated, but there is lack of confirmation. There may be a minor operating risk, but may be feasible. Then there is a C category, project health. Means we have poorly defined a project, marginally unacceptable, existing technology is not adequate, then it means risk or feasibility is doubtful. Whether we want to go ahead or not is doubtful case, and it needs further scrutiny of the project. Then we put a grade D. That project is not attractive and is not feasible. So accordingly, we set the priorities. Some of the recommendations they are straightway rejected, and some of the recommendations they are immediately accepted. Now, once we did the audit kind of a thing, then we have to prepare a report of the energy audit. So this is the standard procedure of preparing the report. At the beginning, we write the acknowledgement, then there is an executive summary, which give the energy audit options at a glance. Because most of the time, management, they don't have enough time to go through the project details, so they just read the executive summary. Then you provide the introduction about the plant. Then what is the production process description. Then energy and utility system description. Then a list of utilities and brief description of each utility. Then what is the detailed process flow diagram, what is the energy and material balance. Then energy efficiency in utility and process systems. Then what are the energy conservation options and recommendations. So like all the data which we have discussed, like what kind of formats need to be prepared, they become a part of the report. We just give the list of options in the terms of no cost, low cost, medium cost, high investment cost, then annual energy and cost savings, payback period, all the financial aspects are being carried out. Then we provide the implementation plan for the energy saving measures. That if okay, we set the priority. Now these projects they have to be implemented in some sequenced or phased manner. So that complete activity chart is provided. Then some annexures, some data collection details, anything is required, they are put as the annexure. Now this is one of the standard format or some of the guideline to prepare an energy audit report. And when we talk about the summary of energy saving recommendations, when we write down energy saving recommendation as a first, there will be a detailed sheet for like energy saving measure separately. But when we have prepared the sheets for say 10 measures, then from those sheets we calculate the key points like what is the recommendation, what is the annual energy saving, what is the annual cost saving, what is the capital investment, and what is the simple payback period. So this is the summary of all the energy saving recommendations. In actual, this is the summary which is prepared from the detailed analysis of the each energy saving measure, where we do all the calculations. We work out, okay, this light will operate for so many hours. So all those data calculations are there. So all detailed data calculations are there, from where at the end we put some recommendation. Then all the recommendations, they are compiled together from all the data sheets. Then types and priority of energy saving measures, as I discussed, that we put them grade A, B, C, D and all, or we put in the terms of low cost, medium cost and high cost. So when we have made the recommendations, they can be put into these three categories. Like priority, we set the priority for the energy recommendation measures. Like first we said no investment, because it's just the operational improvement, and a bit of housekeeping is enough to improve the energy process of the industry. Then there can be a low investment, short to medium term. Say there are some controls are being changed, some equipment is being modified, or some process changes there. Then the third, that is high investment, where we have made use of energy efficient devices. There is some product modification or there is some technology change. So from all the recommendation measures, we have compiled them. Then we made a summary of them. Then we set a priority to all the energy recommendations. Now the third is the post-audit phase. So whatever energy action plan has been prepared on the completion of energy audit, it lists all the energy conservation measures which should be implemented and suggest an overall implementation schedule. We provide the complete action plan. Now, once the audit is covered, that doesn't mean that the auditor now is not bothered or concerned with the industry. So we have to monitor them, and we have to get the feedback from the industry. Like what is the electricity power consumption? We evaluate what recommendation we made, whether they are implemented or they are not implemented. If they are implemented, then what are the energy savings actually taking place? So that complete follow-up action is there, which may be after 6 months, after 4 months, or after 1 year, and that period can be specified at the time of the getting the order for the energy audit. So these are the three phases of the energy audit, any detailed energy audit. Phase 1, phase 2 and phase 3, that is a post-audit phase. So this is a brief view of carrying out the energy audit in the industry. These are the different steps involved in carrying out the energy audit. Now, when we have to carry out the energy audit, we may need some of the instruments. First thing, we have an apprehension that if we have to carry out energy audit, we need a very sophisticated energy audit instruments. Sometimes only 1 or 2 basic instruments are required, and they are more than enough for the general industry. Although for a large industry, you may need some more instruments and all. And there are many parameters which are applicable for one industry or may not be applicable for one industry. Boilers, all the industries may not have. There are different kinds of industries, they have different kinds of processes. So there are certain things which are not applicable to one industry. One industry may have many furnaces, the other industry they may not have any furnaces. So these requirements, they change. So when we talk about the energy audit and all, what are the basic parameters which we need to measure? When we talk about electricity and all, the basic parameters are voltage, current, power factor, then active power, apparent power, reactive power, frequency and harmonics. And then other than electrical are what is the temperature, heat flow, radiation, humidity, moisture, then pH value, then flue gas analysis if there is any combustion, boiler is there and all, what is relative humidity. So these details are required. So I have just listed few of the instruments, but I have given a link. I have given a link where from you can get all the details of all energy audit instruments. It's a simple power analyzer. Again, it comes in the range of starting from 20-30,000 to in the lakhs. But it all requires what current ratings, what details you need. You need a data logger. You don't need a data logger. So these are the instruments which can be put online system. We don't need to stop the motor and all. They directly online take the readings. Then there are thermometers, because temperature is one of the factors which is mainly need to be measured in all types of industries. Now we have a contact thermometer, then we have a infrared thermometers. So infrared thermometers, they are basically used because they are non-contact type. From the distance you can take the temperature reading. So they are used for measuring hotspots in furnaces and the surface temperatures, etc. Then we have the lux meters, because when we have to work out the lighting design of the industry, we have to take the readings of the lux levels. So this is a simple instrument which is used to measure the lux levels. Then there is a combustion analyzer. Then there is a fuel efficiency monitor. This fuel efficiency monitor measures the oxygen and temperature of the flue gas. Calorific values of common fuels are fed into the microprocessor which calculates the combustion efficiency. Then speed is again plays a very important role. We need to check the speed because it may change with the frequency or with the loading. The instrument can be non-contact or it can be just measured from the distance. So tachometer is a contact type. Stroboscope is a non-contact instrument which is used to measure the speed. And there is one link from where you can find out the detail of more energy audit instruments. There are a number of instruments available. I had just put some of the basic instruments which are used. I think this presentation may be available with you. Now, this was all about the energy audit and all. So I have just taken one case study of the electric motors, because when we say that we have to find out the energy efficiency measures in the complete process of the industries. So I can't discuss all kinds of process, whether it's a compressor system, is boilers, or is a HVAC system, or is a like a pumps and all. So I've taken the motors because which is used in many of the processes and all. So I have just taken the thing that when you go to the industry, how to take the data from the electric motors and how can you find out that what are the energy efficiency opportunities and how can you conserve energy in the process. So I've just taken a brief discussion on the electric motors. So I will just go through fast because I have not covered the fundamentals, assuming that all electrical motor fundamentals are clear to everyone because all of us are from engineering background. So when we talk about the electric motors and all, these are some of the basic characteristics which needs to be understood. In fact, in addition to this, one must know what is the torque speed characteristic of the motor. And when we say electric motors, most of the industry motors, they are comprises of three-phase induction motors. And we call three-phase induction motor as a workhorse of the industry. So all the discussion on electric motor is pertaining to a three-phase induction motor. So one needs to know what is the torque speed characteristics of the motor, then how the power factor and efficiency of the motor varies with the load. Now we see that as the load drops, the efficiency also drops, even the power factor drops. So motor operates a very low power factor at the lesser loads. As the motor gets loaded, the power factor gets improved. Now, these are some of the parameters which affect the efficiency of the motor, like what type of motor we are using, what is the speed of the motor, what is the capacity, what kind of enclosure we have used, and what are the operating temperatures, whether the motor is original or we have done the rewinding of the motor, then what are the loading conditions of the motor, then what is the age of the motor. More or less, age further depends on the maintenance part only. That age is, you can say, a function of the lubrication. Then it depends on if there are excessive high temperatures, then the age of the motor gets reduced. If there is any dusty environment, humid environment, or there are mechanical stresses due to load, all these things, they affect the age of the motor. Otherwise, if all those things are perfectly fine, the motor works for 20-30 years, it's not an issue. Now, these are I had discussed what are the main factors which are affecting the performance of the motor. Now I have listed some of the energy efficiency opportunities and I have discussed each opportunity one by one. So what first thing is reduce underloading, because, or you can say avoid oversized motors, because if the motor is underloaded then the efficiency and power factor goes down. Then the size the motor to the variable load, because sometimes the load is not constant. That part I discussed in that point only. Then power quality should be better, because if the power quality is not good, there are voltage or current unbalances, then that will affect the performance of the motor. Then rewinding, quality of rewinding affects the motor performance. Then power factor correction by capacitors. Then maintenance needs to be improved for the motor. Then there is a speed control of the induction motor. Then at the end we say that use energy efficient motors. Now I discuss all the points, like at a glance I can say, okay, when you go to the industry, these are certain areas where you can find out the energy efficient measures. So take take the data of the motors, then just analyze each point and then you can give your recommendations. Now, why the motor is underloaded? There can be two reasons. One is when we selected the motor, we kept a large safety factor. So this safety factor is good when we are designing the buildings or earthing designings and all. But when we are motor is designed and we have kept the safety margin, what will happen? That we have chosen an oversized motor for a particular application. And when the motor is running, most of the time it is operating at a partial load, so efficiency is low. So, or sometimes what happens that say we have used the motor for a particular process, but that equipment itself is underutilized. So it is not fully utilized. So motor load is less. Then sometimes happens that when we have to buy a new motor and all, what the designer has thought that if there may be fluctuations in the voltage, sometimes the voltage level goes down. Now he wants that the performance of the motor, the output of the motor remains constant. So he goes for the oversized motor, so that even if the voltage is low, the power output remains same. Now what happens that sometimes we need a high starting torque. So for high starting torque, we choose a motor of the higher size. Now that is why that we need to understand what are the speed torque characteristics of the motor. Now instead of choosing the high size motor, choose the motor which has a high starting torque, but the motor should be as per your load rating. So what are the consequences? The motor losses increases, the efficiency goes down and the power factor goes down. And when we have to calculate the motor loading, this is how the motor loading is calculated. Actual operating load of the motor divided by the rating capacity of the motor. This is how do we work out that this is the percentage loading on the motor. Now, if the motor is underloaded, what kind of recommendation you can give? Replace with a smaller motor if motor operates at less than 50% of the load, but don't replace the motor if the motor is operating in the range of 60 to 70% cost, because then you won't be able to recover your cost. And then if the motor is consistently operating at load less than 40%, then delta motors, most of the time they are delta connected motors. You can wire the motor, there can be a wire reconfiguration and the motor can be connected in the delta. This is one of the very cost effective methods, but when we do this, the speed also goes down. Now this recommendation should not be given to the production facility whose output is related to motor speed. So when we give the recommendations, we need to understand the working of the motor, we need to understand what is the working of the process. So it may not happen that we have gone for the energy efficient measure, but that has affected the quality of the production. Now coming to the second point, that is sizing to the variable load. Now what happens that motor selection is based on the highest anticipated load, which results in expensive and risk of the underloading. Now what happens, say there is a complete industrial process. Now during the complete process, the motor may be overloaded for just a moment, for just very small duration the motor is overloaded. Now instead of taking the motor of that higher size, take the motor of the base load and the motors, they are provided with the service factor, which is 15% or above can be taken. So service sector provides the overload facility for that motor. So it means like during the process, the momentary during that period, the motor can be overloaded. But most of the during the process, the motor will operate at the full load and the efficiency will be high. So that is that sizing to the variable load. Now again, this recommendation should not be given if there is a risk of overheating. Say there are extreme load changes. So what will happen, that motor will not have enough time to cool down. So that's what happens, that if the motor is not cooling down enough, then if you have chosen the undersized motor, then it may result into the overheating, and that will affect the performance of the motor. Otherwise, if the process is such that overload is momentary, then choose the motor with a low rating and let the motor be overloaded for a small duration. Now coming to the power quality, the poor power quality means there are very fluctuations in voltage and frequencies. And voltage unbalance means all the three phases of the motor, they are not equally loaded, so there are unequal voltages. There are unequal voltages in three phases of motor. The voltage unbalance may occur because the transformer from where the supply is coming, all the three phases they are not equally loaded. That is just a small example. If there is a voltage unbalance of 0.3%, then current unbalance will be 0.4% and the temperature rise won't be there. But if there is a voltage unbalance of 2.3%, then the current unbalance will be 17.7% and temperature increase will be 30 degrees Celsius. So if the voltage unbalance is 5.4%, the temperature rise is 40 degrees Celsius. And the winding insulation life is reduced by 1/2 for each 10 degrees Celsius increase in the operating temperature. So this is the effect of the power quality on the performance of the machine. If there is an unbalance in the supply, then it will result into the temperature increase, which will result into the lower insulation life of the motor. Now, the voltage unbalance, it should be kept within the limit of 1%. The major options are balance single phase loads equally amongst all the three phases, segregate single phase load which disturb load balance and feed them from a separate line or transformer. Then load and power factor improvement by matching the power factor capacitors. Then the minimizing the voltage drops from substation to the motor terminals. So the cable should be such, either the appropriate size of the cable should be chosen or the distribution point just to be near to the motor terminal. Now the next point is the rewinding of the motor. Now sometimes happens that in the industry, more than 50% of the motors, they are the rewound motors. Now what happens with the rewinding of the motors? They reduce the motor efficiency. Now if the rewound motor has to be used, then there are certain instructions. Get the motor rewound only from the certified firm and see that the motor maintains the original motor design. And if the motor is 40 HP and greater than more than 15 years old, then instead of rewinding, buy the new motor. Replace it with the energy efficient motor and buy the new motor if the costs are less than 50 to 65% of the rewinding cost. Sometimes there happens that we should compare the test results with the test results of the original motor. So once the motor is rewound, ask the person to perform the test in my presence, take the data sheets and take the test reports and compare with the original. So the original design should not be changed after the rewound, otherwise you will not even come to know that what harm it is doing to the industry in the terms of the energy consumption. Then coming to the improving power factors, because the motors, their operating power factor is bit low. So when we improve the power factor, basically it decreases in kVA loading, it reduces the losses and it improves the voltage regulation and the efficiency of the plant system. But when what happens when we have to start the induction motor, we go with the capacitor switching. And when we are using the capacitor bank to improve the power factor of the system, making sure that the size of the capacitor is not more than 90% of the no load kVAR of the motor. Otherwise, what will happen, that the magnetizing current will become very high. So if this condition is also undesirable. So capacitor rating should be kept up to 90% of the no load kVAR of the motor. Maintenance plays a very important role. So when you have to audit, just check how the equipment machinery is maintained. So there is a checklist to maintain the motor efficiency. First thing, inspect motors regularly for wear, dirt and dust. Check the motors for overload, underloading, whether the motor is overloading. So that complete recording can be taken, that what was the current flowing in the motor. So from then we can work out what was the percentage loading of the motor, and we can plot our own curves to find out the load pattern of the motor. Then lubricate appropriately. Lubrication should be proper. Even if there is excess lubrication, that is also harmful. It may saturate the motor insulation. Then alignment of the motor and equipment is very essential, and adequate ventilation is also required, because if the temperature increases, then the chances are there that you have to go for the rewinding of the motor because of the insulation failure. Now coming to the starting of the induction motors. Now we all know that at the starting the induction motor develops more torque than required, and that stress is transferred to the mechanical transmission system, resulting in excessive wear and premature failure of the chains, belts, gears. And at the starting there is a high inrush current flowing in the system, which is normally 6 times more than the normal current. So we can recommend the soft start of the induction motors. Basically these are the reduced voltage soft starters. They deliver a controlled release of power to the motor. So there is a smooth stepless acceleration and deceleration of the motor. Advantages of soft start are that there will be less mechanical stress, power factor will be better, lower maximum demand because there won't be inrush current at the starting. Now sometimes what happens, there are huge motors installed in the industry. So when the motors are starting, say 2 or 3 motors are started together, there will be a high inrush current flowing in the system. It may happen that your maximum demand has exceeded the predefined value, so that sometimes it may ask for the penalty from the electricity utility. Then it requires a less mechanical maintenance. Now I have just taken the 2 examples. That is a soft starter. There are 2 curves, time, current versus time, then mechanical stress versus time. If we see that if we use direct online starter or start delta starters, in both the cases we get the current surges. But if we are using the soft start, there is a smooth start. The ramp is very smooth, so there is no power surge. And if we talk about the mechanical stresses, if we use direct online starters, there are mechanical surges. But with the soft starter, the surge is not there and there is a smooth start. Now coming to the major point, like we have to work out that which is the area, which is the device which has the maximum energy efficiency measures. When we say that loading of the motor, what constitutes load? Basically load refers to the torque output and corresponding speed required. So it means torque and the speed when we talk about the load. Now there are the 3 types of the loads on the motor. We have a constant torque load, we have a variable torque load, and we have a constant power load. When we talk about the constant torque load, the output power varies with the speed, but torque is constant. And the common examples are conveyors, rotary kilns, constant displacement, pumps. When we talk about the variable torque loads, the torque varies with the square of the operation speed and the power varies as the cube of the speed. So all the centrifugal pumps, fans, HVAC applications, they have the variable torque loads. And this is the area where you get the maximum energy saving. Then we have a constant power loads where the torque changes inversely with the speed. The examples are machine tools, vibrating conveyors, punch presses, rock crushers, etc. Now, if we see, we have a constant power, constant torque and variable torque, and if we find out what is the energy saving and the speed, we find out that the constant power loads, like what are the constant power loads, torque changes inversely with the speed. There is hardly any scope of the energy saving. So maximum saving is here, that is the variable torque. Even constant torque loads, they offer some opportunity to the energy savings. So it means the centrifugal fans, pumps, they have the maximum potential for the energy saving, where we use the variable speed drives. So largest potential for energy saving is with the variable speed drives, and it finds application in variable torque application, that is centrifugal pumps and fans, where the power is in directly cube of the speed, varies as the cube of the speed. So I just give you a small example. If the motor runs at 90% speed, power consumed will be 73%. If the motor runs at 80% speed, the power consumed will be only 51%. Although constant torque loads are also suitable for the variable speed drives. Now, when we talk about that, the motor has two parameters load. One is the torque, another is the torque and the speed. The frequency of the power going into the motor will control the speed, and the voltage applied to the motor will control the torque of the motor. So this is one thing. I have not discussed the variable speed drives because main focus was on the energy audit and all. So you can see that what are the different types of loads. Then the variable torque loads, they are the areas where you can find out the maximum energy efficiency. Now last is the make use of the energy efficient motors. They are the energy efficient three-phase induction motors. These motors, they have the increasing low losses, and the efficiency is nearly 3 to 7% higher than the standard motors. There is a wide range of the ratings. These motors, they are no doubt more expensive than the standard motors, but the payback period is very less. So if we see the curve of the standard motor and high efficiency motors, we can see that the energy efficient motors, they are more efficient than the standard motors. Now energy efficient motors, they have many more advantages. One thing is that operating costs are less, and additional benefits they have, that they have the extended warranty, they have the better tolerance to thermal stresses resulting from stalls or frequent starting. These motors, they have the ability to operate in higher ambient temperatures. Then they have the increased ability to handle overload conditions due to cooler operation, and the surface factor is 1.15. So it means they can run for 15% overload without the temperature rise. Then there are few failures due to the impaired ventilation. That is, if ventilation is not adequate, the temperature rise is basically low. So there are less chances of the failures, and they are more resistant to the abnormal operating conditions such as under voltage, over voltage, or phase unbalance, etc. So these are more benefits of the energy efficient motors. Now question arises that when you have to give the recommendation to the industry, which motors they need to be replaced. Now energy efficient motors can be considered if there is a new installation, some new setup or energy is going for the extension. Now for all the new installations, go only for the energy efficient motors. There is no need of buying the standard motors. And when there is a major modification done to the existing facilities, then go for the energy efficient motors. And if you are buying the new equipment like air conditioner, compressors, then it should be energy efficient. And when we have to replace the failed motors, or we have to purchase the spares and all, or when rewinding has to be done, then instead of rewinding, just replace them with the energy efficient motors. Oversized motors, that is underloaded motors, they can be replaced with energy efficient motors. And sometimes the energy, they have kept a budget for the energy management program or preventive maintenance program. In those cases, the motors can be replaced as a energy efficient motors. And then you can do the calculation that if the motor is replaced, then what is the kilowatt saving, and this is the formula by which you can put the data and find out the kilowatt savings. And then there are international efficiency classes. These are the latest classes which are applicable all over the world. We have three classes: standard efficiency, high efficiency, and premium efficiency. IE stands for international efficiency. There is a super premium efficiency, IE4, that is the for asynchronous and synchronous motors. Now, these are the audit worksheets for the electric motors that when you go to the industry, you can calculate you can take the data of the motors in this format. So this is the motor load analysis that we take the data and put we take the data, then we do the load analysis, we find out what is the motor loading and all. Then at the end, we are working towards the star and labeling scheme. So in the industry, the government has given many products for which the star labeling is mandatory. For some of the products, it's the voluntary. So whether it's your home or it's your industry, just go for the star rated products. And B has changed the star label. So this is the standard star label which we all have seen at our places, even at the workplaces also. All refrigerators, air conditioners now are coming with a star label. So this star labeling system has really brought a revolution in the country, because the people, whether they know anything technical about the product and all, but they at least know that it's a 3-star rated or 4-star or 5-star rating, and the people now they feel proud that okay, I have bought a refrigerator with 4-star rating, or I have bought a air conditioner with a 5-star rating. So earlier this was a star label where the stars are being mentioned. Then there is the energy efficiency is mentioned. What is energy consumption? If it's a air conditioner, then what is the energy efficiency ratio? In the new label, this thing is marked in the green color now. Now you see, as the technology is changing and all, so benchmarks are changing every year with the development of the new technologies. Now if you buy new product, you must have seen that they have mentioned that what is the period for which that star rating is applicable. Normally it's 2 years. So they have mentioned on the label that this is valid, this star rating is valid for this period to say 1st Jan 2014 to 31st December 2015. So it may happen that say you have bought a 5-star rated product today, but next year technology changes, so your 5-star rated has become 4-star rated in the next range of the products. And at the end, I would like to share that there are some energy audit of the buildings. We give some kinds of assignments to our students, like conduct energy audit of your house, institute, and find out energy savings and see if the existing equipment can be replaced by the energy efficient equipment. And then we give the exercise to our students, like to find out that if there is a product and there are star labeled products from 1 star to 5 star, then what will be the energy saving if comparing it with the no star rated appliance. So they work out the exercise and work out what are the energy efficiency measures. So we provide them the worksheets and all. So I have just taken one example, like at the first they have to write down what is the name of the equipment. They have in the second column, this worksheet you can change it. You may come up with some better idea and all. I had just put because I feel that this is covering almost all the points. Then what is the rating? What is the quantity? What is the total power rating in kilowatt? Then what are the operating hours per day, power consumed per day, power consumed per month, that what are the charges per month. So we have listed some of the components that if it is lighting, they can work out whether it's incandescent bulb, fluorescent tube, CFL, what kind of light fitting is being installed in the building. So same exercise can be repeated for all the equipments. I have listed equipment in against this equipment, all the parameters remain same. So due to space constraint, I just listed, like air conditioners. Again, you can further segregate air conditioner, whether 1 ton, 1.5 ton, 2 tons, whether it's an inverter technology or something. Coolers, then what kind of a cooler, refrigerators. So any devices, you can list down the devices, or student may write down what are the additional devices. So as such, we fill the data for all there. At the end, we total them. What was the total rating? What are the total charges per month? So this gives the first thing, give the idea to a student that what is energy consumed by the products, like what are the charges against each product. So it's not only monthly charges. You can from there you can also work out that each component is consuming how much energy in a month. And if you are using a DG sets, then we specify what is the diesel consumption and how much electricity is generated by the DG set. Then after taking all the data, this is the students, they compile the data in this format. What is the energy consumed by device in a day? They can compile the data from the sheet also. From there itself the calculations can be done, or they can be done in this format. So one and the same thing. So energy consumed by a device in a day, what is the power rating of the device, what is the number of operating hours, then total power consumption per day, then electricity consumed in a month, what is the unit rate of electricity by the utility, then what is the unit rate of electricity generated by DG set. They themselves calculate, okay, what was the diesel consumed and what was the units generated by the DG. Then they calculate the electricity bill of the industry. So what is the total unit consumed by the electricity and what was the cost involved due to the operation of the DG set if it is applicable. So this is how it's a small kind of an energy audit of any building. Now this part is applicable to the industry also because they have the offices and all. So this exercise will be carried out there also. But for students, to spread the awareness amongst the students about energy efficiency, energy conservation and all, they can be given these kinds of small exercises and they can be asked to work out that what was the energy bill of the industry of the building, and then after going through them, then I can say then they can work out that if they can replace the existing technology with the energy efficient technology, then what will be the payback period, and if we replace the no labeled equipment with 1-star label or 2-star or 5-star, then what will be the energy saving. So this is one of the practical exercise which we ask our students to do. And since these all calculations, they are meant for everyone, like whether you, me, everybody, whether person is technical or non-technical, domestic sector is consuming 22% of the energy consumption. So everybody should be aware about the energy and its importance. And then the students, they are being asked to study the electricity bill because sometimes they really don't know how to read the electricity bill. But once they have to fill the data in the performer, at least they bother to go through the energy bill of their house and they see what are the rating, and some awareness comes to, okay, this was the electricity bill of the house. Otherwise the father or mother, they are paying the electricity bills, they are damn bothered that what was the bill of the industry and all. But at least these activities, they spread the awareness amongst our young engineers. So I would say the future of children, the future of our planet, it's in our hands. That's why energy matters. So every person is the right person to act. Every moment is the right moment to begin. The time to act is now. So that's all. If you have any queries, you are open to it.
Madam, when we ask for energy auditor to come to, let us say I have come from one institute and I'm asking the energy auditor to come to my institute, what details I must give to him for the auditing to be done?
First thing is not your responsibility. Auditor will ask the details from you. Auditor will ask, normally like we have prepared some standard formats. So like I give you that preliminary audit is just a walkthrough audit, and an auditor visits industry, just get familiar with the procedure. But normally what we happen, sometimes we just provide the performer to the industry and we get the inputs from the industry just to work out that what time frame will be required, what time we need to spend in the industry, and how much charges we need to get from the industry. So we just work out what volume of work is required. And if you have to get the energy audit done, then it's not your problem is the energy auditor to see that what he needs to get the information.
What charges energy auditor?
It can vary from thousands to lakhs. It all depends on the amount of the work done.
Madam, they have work. So manager is auditor and then
No. When the energy auditor visits you, it can be a person. Normally, the auditor is at least accompanied by one technician. Take the reading set. Now, depends on what is the size of the industry. I told in the beginning that the type of the audit depends on the what is the size of the industry and what is the requirement of the industry. So it can be a team, external auditors who are coming to audit your organization. It can be a team of the professionals. There can be one or two auditors or one or two technicians along with them, or there can be one auditor, one technician if there is a small scale industry. Now, when they visit the industry or the organization, no doubt they have to take the input data from the industry. So, when we see the team is being formed, then the management depute some of the members of the industry with the external team. Now, those members may be at the position of manager, like shop floor in charge, some of the technicians of the industry, like who are the working on them, some senior persons. So, all of them, they form a team. Because ultimately the external agency has to take the data from the internal members only. So their cooperation is required.
Do you have any doubts? Huh? Yeah, centers. Hello, sir. Yes, you can ask.
Ma'am, by performing energy audit in industry, as stated, where you different types of instruments for taking readings. But my question is that whether the readings provided by data loggers are.
Your question, excuse me, it's not clear, sir. You keep your mic little far.
Hello?
Keep your mic little far and speak because it is not like echo.
Ma'am, by performing energy audit in industry, as stated, we are using different types of instruments for taking readings as an energy audit. But my question is that whether the readings provided by data loggers are considered as effective parameters of energy audit.
Data?
He's telling.
Yeah.
Data logger.
We couldn't understand the question clearly. We heard the word data logger, okay, and other things we couldn't hear properly. Yes. Keep your mic away. Tell one sir. Your mic away. अभी बात करो. Don't take your mic to your please don't use the mic. Keep it away and tell ask the question now. Yeah, now you ask. We can hear you.
Ma'am, whether you are getting my voice or not?
Getting there. Hello. Okay. मैंने सोचा उन्होंने कहा कि कुछ और आती सी छोटा सा.
So will you please repeat the question like you are talking about?
Chat में
You can, sir, you can ask the question in your chat. Chat के window में, like in your chat window, please type the question. Your voice is not. We couldn't get your voice clearly.
Ma'am, data loggers readings are reliable or not?
Okay, data loggers readings are
Data loggers are very much reliable. Normally, if you have bought equipment with the data logger facility, it must be expensive and accurate equipment. So data loggers, you can take the readings from there only. So you got your answer?
उनको कनेक्ट करना है एक बार.
Sir, if the question, sir, can you hear me?
Okay, unka reply. They understood. Okay. Okay, so now we have come to the end of the session, and I really thank the coordinators at various nodal centers and the participants here, and I hope this session would have been a very useful session for you. And now we are just